Hi, hello, this is Gary teaching 10 mathematics, the chapter real numbers. Here is the alternative calendar first week designed by SCRT. And now this is the actual schedule for the first week, second week, third week and fourth week. As it is not clear, let us zoom in to first week. The teacher may engage students by sending them different decimal numbers and asking them to distinguish between rational and irrational numbers. Students have to justify their answer. And WhatsApp groups or emails can be used for this interaction. Another point, the teacher may send contests in which HCF and LCM are used. And the teacher may ask students to send some more such contests. Now, basing on this, in this video, let us learn the different sets of numbers and the different types of decimal numbers. And let us also know what type of decimal numbers are rational numbers and what type of decimal numbers are not rational numbers. And at the same time, let us also know how to frame questions on HCF and how to frame questions on LCM. Okay, dear students, here are the real numbers, and let us go to the introduction to real numbers. You see, look at this diagram. What can you see in this diagram? Yes, it is a bunch of roses. Now, how many roses are there? You count. Yes. If I ask you to count, you may start from 1. You may say 1, 2, 3, 4, 5, 6, 7, 8 and 9. Therefore, there are 9 roses in this bunch of flowers. Look at this diagram. These are our freedom fighters. If I ask you to count how many are there, then you may start counting like this: 1, 2, 3, 4, 5, 6 and 7. In this diagram we have 7 famous freedom fighters of India. If we look at this diagram, here are our Indian soldiers, and these soldiers are hoisting a flag and they are safeguarding our border. And if I ask you to count how many soldiers are there, then how do you count? Yes, you can start from 1. You may say 1, 2, 3, 4, 5, 6, 7, 8 and 9. You may say that there are 9 soldiers, and these 9 soldiers are safeguarding our territory with our national flag in their hands. Look at this diagram. This is the moment when our Indian cricket team won the World Cup. If I count how many Indian players are there in the team, then how can you count? You may start from 1. You may count like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. You may say that there are 15 members in our Indian cricket team who won the World Cup. You see, in all these cases, you started counting from 1 and you counted like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. These numbers are used to count the objects. Therefore, these numbers are called counting numbers. Okay? You can use the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. You can use these numbers to count the objects. Therefore, they are called counting numbers. And you see, if you look at the numbers may start from 1. In this case, you may start counting from 1, 2, 3, 4, 5, 6, 7, 8, 9 and later by getting a number 10 in which we have 1 and 0. In the next number 11 we have 2 ones. and in the next number 12 we have 1 and 2, like this. Therefore, we use the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. These 10 are called digits, and these digits are useful to form numbers. Any number can be formed by these 10 digits only. Therefore, how many digits are there? We have 10 digits. And what are they? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. These 10 are called digits, and we can form numbers by means of these digits. You see, for example, 1, 5, 10, 13, 28, 99, 123, 999, 1000 and so on. And all these numbers are formed by means of these 10 digits. Now, what are the different types of sets of numbers? You come across these sets of numbers in your previous classes. Yes, the first set of numbers is set of natural numbers. Natural numbers is denoted by the letter n, and these set of natural numbers may start from 1. 1, 2, 3, 4 and so on are called set of natural numbers. In this set of natural numbers, what is the least natural number? Good. 1 is the least natural number. And what is the highest natural number? Good, we cannot say. Therefore, the infinity is the highest or the maximum natural number. There is no highest natural number, but the least natural number is 1. Now, the difference between any two successive natural numbers is always 1. And again, if you add 1 to a preceding natural number, you will get the next natural number. For example, if you add 1 to 1, you will get 2. If you add 1 to 2, you will get 3. If you add 1 to 3, you will get 4. If you add 1 to 4, you will get 5. And so on, you can write all these natural numbers. Since n is the first letter in the word natural numbers, these natural numbers are denoted by the letter n. Next is whole numbers. Whole numbers may start from 0. 0, 1, 2, 3, 4 and so on is set of whole numbers. And this set of whole numbers is represented by the letter W. This set of whole numbers is nothing but the set of natural numbers plus 0. If you add 0 to set of natural numbers, you will get set of whole numbers. Therefore, you can write set of whole numbers as 0, and this is union. 0 union n means natural numbers union. Unions means you have to sum up. Natural numbers plus the number 0. You will get set of whole numbers. And the next is set of integers. Set of integers is represented by Z. You see, the set of natural numbers is represented by n, and set of whole numbers is represented by W, as W is the first letter in whole numbers. But whereas in this case, integers are represented by Z, but not by I. Why? Because these integers are also called as Zahlen numbers in German. In German, you can call integers as Zahlen numbers. You can represent the integers with Z, Zahlen. May start with Z, therefore these are represented by Z. These integers may start from minus infinity to minus 2, minus 1, 0, 1, 2 and so on. This is nothing but the negative numbers union whole numbers. If we add negative numbers to the set of whole numbers, you will get integers. And in other words, if we add negative numbers and 0 to set of natural numbers, again you will get integers. The next set of numbers is rational numbers. The rational numbers is represented by the letter Q, but not with R. Q stands for quotient. You see, rational number is a number which is in the form of P by Q. Any number in the form of P by Q is called a rational number, but the condition is P and Q should be integers and Q should not be equal to 0. Rational numbers represented by the letter Q, and a number in the form of P by Q where P and Q are integers and Q not equal to 0 is called a rational number. A rational number is a number which is in the form of P by Q, a fraction form, P by Q, numerator by denominator, where both numerator and denominator should be integers. and q should not be 0. The denominator should not be 0. Such type of numbers are called rational numbers, and these rational numbers are represented by the letter q. Q stands for quotient. Every natural number is a rational number, every whole number is a rational number, every integer is a rational number. Therefore 0, 1, minus 3, 1 by 2, minus 4 by 5, and all these are rational numbers. If you come to decimal numbers, 0.125, this is a terminating decimal, a rational number. Every terminating decimal is a rational number. This is 0.333 and so on. It is non-terminating but recurring. 3 is repeating. Therefore, non-terminating and recurring decimals are also rational numbers. And this is 12.4 and 7 is recurring. Therefore, it is again a rational number. And square root of 4 value is 2. Therefore, root 1, root 4, root 9, root 16, root 25, and all these are rational numbers. If it has perfect square root, then they are called rational numbers. Okay? Therefore, what is a rational number? A number which is in the form of p by q, where p and q are integers and q not equal to 0, that is denominator is not 0. Both numerator and denominator should be integers. Such type of numbers are called rational numbers. Please keep in mind, every natural number, every whole number and every integer is a rational number. You might have a doubt that if you look at 0, how 0 is a rational number? Because can you write 0 in the fraction form? You may have such doubt. Yes, 0 can be written in the fraction form. How? You can write 0 as 0 by 1, 0 by 2, 0 by 3. Therefore, it is in the form of p by q, where 0 numerator is a rational number, and of course denominator is not 0. 0 by 1, 0 by 2, 0 by 3. Therefore, it is a rational number. 1 means 1 by 1. You can write 1 as 2 by 2. You can write 1 as 3 by 3. Again, it is in the p by q form. Therefore, it is a rational number. Minus 3 means minus 3 by 1. Minus 6 by 2. Like this you can write. Therefore, this is also a rational number. Okay, is your doubt clear? Good. Note, all terminating decimals and non-terminating recurring decimals are always rational numbers. You see, I told you already. 0.125, it is a terminating decimal. 0.333 and so on, it is non-terminating recurring decimal. And 12.4777, therefore it is 12.4 and 7 is recurring, therefore again it is non-terminating recurring decimal. All terminating decimals and all non-terminating recurring decimals are always rational numbers. And the other type is irrational numbers. As you know that the rational numbers are represented by q, now irrational numbers are represented by q dash, or they are also represented with s. An irrational number is a number which is not rational. Right, 1, 2, 3. An irrational number is a number which is not rational. Every non-rational number is called an irrational number. Here are the examples for irrational numbers. Root 2, root 3, 1 by root 2, root 2 plus root 3, root 3 minus root 5, and 3.12568726 and so on, and pi. All these are examples for irrational numbers. Root 2, if you find the square root of 2, you will get a non-terminating and non-recurring number. And root 3 is also non-terminating decimal. 1 by root 2, root 2 plus root 3, and root 3 minus root 5, 3.125682726 and so on. Here, if you look at this decimal number, this is non-terminating, it has no end, and at the same time, nothing is repeating. It is not a recurring number, and it is not a terminating decimal. This type of decimal numbers are called irrational numbers. And again, pi is also an irrational number. Generally, in the place of pi, you may write 22 by 7. As you wrote pi in the form of a fraction 22 by 7, Why it is not a rational number and how can you say that it is an irrational number, you may ask. Here, even though you can write pi is equal to 22 by 7, it is not its exact value. Pi value is not exactly 22 by 7. It is nearly equal to 22 by 7. The value of the pi is very nearly equal to 22 by 7. Therefore, it is an irrational number. Here is the note. Non-terminating and non-recurring decimal numbers are called an irrational number. If you look at these different types of numbers, you may come across natural numbers, whole numbers, integers, rational numbers and irrational numbers. But our chapter is real numbers. Now what is a real number? So far you know natural numbers, you come across whole numbers, you learn what are integers, and you understood what is a rational number, and you also learned that how a number is an irrational number. Now what numbers are called real numbers? This is the name of the chapter actually. What are called real numbers? A real number is nothing but a union of rational and irrational numbers. If we join rational and irrational numbers together, then they are called real numbers. Means the union of rational numbers and irrational numbers together are called real numbers. Real number is nothing but the union of rational numbers and irrational numbers. Q union Q dash is set of real numbers, or Q union S is set of real numbers. S is used to represent irrational numbers. Q dash is also used to represent irrational numbers, whereas this Q is used to represent rational numbers. Therefore, the union of both rational and irrational numbers is called set of real numbers. If you observe this diagram, you can find here is the first circle. This is set of natural numbers. Rational numbers may start from 1, 2, 3 and so on. And this is set of whole numbers. The set of whole numbers may start from 0, 1, 2, 3 and so on. Therefore, every natural number is a whole number. The circle N is included or inside the circle W. Therefore, every natural number is a whole number. Now this is the set of integers. Set of integers may start from minus infinity and end with plus infinity. Therefore, every natural number is an integer and every whole number is an integer. And besides whole numbers, there are negative numbers also in integers. Therefore, both natural numbers and whole numbers are inside the set of integers. And this is the set of rational numbers, which are in the form of p by q and q not equal to 0, and both p and q are integers. This is set of rational numbers. Every natural number is also a rational number, every whole number is also a rational number, and every integer is also a rational number. You see, the circle N and the circle W and the circle Z are the parts of the total circle Q. Therefore, all these numbers are included in set of rational numbers. The different circle represent the set of irrational numbers. Therefore, the numbers which are not rational are called irrational numbers. These irrational numbers are represented by Q dash or S. Now, if you include the set of rational numbers and the set of irrational numbers together, if you sum up all these rational and irrational numbers, you will get set of real numbers. You see now the different types of decimal numbers. The first one is terminating decimals. The decimal numbers which have end in their decimal place are called terminating decimals. For example, 0.7. This decimal place end by 7. And another number 1.239. This decimal part end by 9. And another number 123.009. This decimal place is again end with 9. This type of decimal numbers which have end in their decimal place are called terminating decimals. And we know that any terminating decimal can be written in the form of p by q, can be written in a fraction form. So it is called a rational number. Dear students, if any number can be written in the form of p by q, where p and q are integers and q not equal to 0, then such numbers are called rational numbers. Good. Now you see, the 0.7 can be written in the fraction form as 7 by 10. 7 by 10 is in the form of p by q. Therefore, is it a rational number? Good, it is a rational number. Similarly, 1.239 can also be written in the form of a fraction as 1239 divided by 1000. Therefore, any terminating decimal can be written in the form of p by q, which represents a rational number. Every terminating decimal can be written in the form of p by q. Therefore, it is a rational number. And the second type is non-terminating recurring decimal. Non-terminating, the name itself indicates non-terminating, means it has no end. The decimal number that continues infinitely with repeated pattern is called recurring decimal. Recurring decimal means repeated pattern. Recurring decimal can also be called as repeating decimal. Non-terminating repeating decimal or non-terminating recurring decimal, both are same. A decimal number that continues infinitely with repeated pattern. You can observe this example 0.333 and so on. This 3 is repeating. Therefore, it is called recurring decimal. And is there any end? We have 0.333 and so on. There is no end. Therefore, it is non-terminating. And since the decimal place 3 is repeating, it is called non-terminating recurring decimal. And another example is 12.153535353 and so on. This decimal number is also has no end. It continues up to infinity. Therefore, it is non-terminating. And at the same time, the decimal part of 53 is repeating. 535353. 53 is repeating. Therefore, it is a recurring decimal. A decimal number that continues infinitely with repeated pattern are called non-terminating recurring decimals. Now, note, any non-terminating repeating decimal can also be written in the form of p by q. You can write every non-terminating recurring decimal as a fraction in the form of p by q. As it is written in the form of p by q, so you can call it as a rational number. It also comes under rational numbers. For example, 0.3333 and so on. This can be written in the form of p by q. If you divide 1 by 3, then what will be the quotient? You once check. If you divide 1 by 3, you will get 0.333 and so on. It has no end. Therefore, it is non-terminating. And this 3 is repeating. Therefore, it is non-terminating recurring decimal. Every non-terminating repeating decimal can be written in the form of p by q. Therefore, it is a rational number. Now, the third type of decimal numbers are non-terminating and non-recurring decimals. A decimal number that continues infinitely without repeated pattern. Without repeated pattern is called non-terminating and non-recurring decimals. For example, 0.34132 and so on. Here no part of this decimal part is repeating. Therefore, it is non-recurring decimal. And at the same time, there is no end to this decimal part. Therefore, it is non-terminating, non-recurring decimal. Any non-terminating and non-recurring decimal cannot be written in the form of p by q. You cannot write it in the form of a fraction. Any non-terminating, non-repeating decimal cannot be written in the form of p by q. Since it cannot be written in the form of p by q, it is not a rational number. So, if a number is not rational, then how can you call it? Yes, good. If a number is not rational, then you can call it as an irrational number. Therefore, out of all the three types of decimal numbers, first two types, that is terminating decimals and non-terminating recurring decimals, can be written in the form of p by q, and they are rational numbers. And the third part, and the third type, non-terminating non-recurring decimal, as it cannot be written in the form of p by q, it is not a rational number and it is an irrational number. Is it clear now, students? Is it clear? Can you understand what are the different types of decimal numbers? And out of all the three, what type of decimal numbers are rational numbers and what type of decimal numbers are irrational numbers? Can you distinguish between the different types of decimal numbers? Good. Okay. Now, let us know the fundamental theorem of arithmetic. Let us see its statement. The fundamental theorem of arithmetic states that every composite number can be expressed as a product of prime factors in a unique way. I shall repeat, every composite number can be expressed as a product of prime factors in a unique way. Means in only one single way. Unique means in only one way. You may try to understand. First of all, what is a composite number? Composite numbers means a number which is having more than two factors is called composite number. A number with exactly two factors is called prime number, and a number which is having more than two factors is called composite number. Now every composite number can be expressed as product of prime factors in only one way. Now let us try to understand this statement with a given example. Now if you look at this example, 30, you can write 30 as 2 into 3 into 5. 2, 3, 6, 6, 5 is 30. You see, you can write 30 as the product of three prime numbers. 2 is a prime number, 3 is a prime number, and 5 is a prime number. You can write 30 in only in this way, and you cannot write 30 in any other way as the product of prime numbers only. Of course, you can write 30 as 6 into 5, but 6 is not a prime number. Therefore, you can write 30 as the product of prime numbers in only one way, and there is no other way. Similarly, look at 36. You can write 36 as 4 into 9. This 4 is 2 into 2, and this 9 is 3 into 3. 2 into 2 is 2 square, and 3 into 3 is 3 square. Therefore, you can write 36 as 2 square into 3 square. You can write 36 as the product of prime numbers in only one way. Similarly, 60. 60 is nothing but 4 times of 15. 4 is 2 square, and 15 is 3 into 5. Therefore, 60 can be written as 2 square into 3 into 5. This is the only one way in which 60 can be written as the product of prime numbers. This is called fundamental theorem of arithmetic. Every composite number can be expressed as the product of prime factors in a unique way. Now go for another example, 420. This 420 you can write it as 2 into 210. Again you can split 210 as 2 into 55, and you can split this 55 as 5 into 11. Therefore, finally 420 is equal to 2 into 2 into 5 into 11. 2 into 2 is 2 square into 5 into 11. Therefore, 420 can be written as the product of prime factors as 2 square into 5 into 11. This is again an unique way. This is what is fundamental theorem of arithmetic. Note, writing any composite number in this form is called exponential form or prime factorization method. You see, you wrote 30 as 2 into 3 into 5, and you wrote 36 as 2 square into 3 square. You wrote 60 as 2 square into 3 into 5. We wrote 420 as 2 square into 5 into 11. All these numbers can be written as the product of prime numbers. This type of writing all these numbers is called exponential form, and the method is called prime factorization method. The next concept is HCF and LCM. HCF stands for highest common factor, and LCM stands for least common multiple. You come across what is HCF and what is LCM in your previous classes. Now here is a question. Find HCF and LCM of the numbers 60 and 75 using prime factorization. I shall repeat. Find HCF and LCM of 60 and 75 using prime factorization. Here is the solution. First of all, write 60 as the product of prime factors. 60 is nothing but 2 into 30. Again 2 into 2 into 30 is 15. Again 15 is 3 into 5. Therefore 60 is 2 square into 3 into 5. And the second number is 75. 75 can be written as 3 into 25. This 25 can be written as 5 into 5. Therefore, finally 75 is equal to 3 into 5 square. Now we wrote the factors of 60 as 2 square into 3 into 5, and we wrote the factors of 75 as 3 into 5 square. Now we have to find the HCF. HCF means it is the product of common factors with their respective least exponents. Here HCF is nothing but the product of common factors with their respective least exponents. We look at these two products. Here what are the common factors you pick up? Here the factor is 2, but there is no 2 in 75. Here is a factor 3 in 60. 3 is also a factor of 75. Therefore HCF is equal to 3 in 2. Here 5 is a factor of 60 and 5 square is a factor of 75. Therefore which is common? 5 and 5 square, the common is 5. Otherwise, now out of these common factors, here the exponent is 1. Here the exponent of 5 is 2. Therefore what is the least exponent? 1. Therefore you have to consider 5 only. HCF is 3 into 5. These are common factors in both 60 and 75. What is the product of 3 into 5? 3 into 5 is 15. Therefore HCF of 60 and 75 is equal to 15. HCF is nothing but the product of common factors with their respective least exponents. Now let us find LCM. In finding LCM, we have to consider the product of different factors with their respective highest exponents. In the previous case, we took common factors and we took the least exponents. And in finding LCM, we have to take all different factors with their highest exponents. You see, here 2 is a factor, but here there is no 2. Even though there is no 2 in 75, you have to take this 2 square to find LCM. The highest power of 2 here is 2, and here the highest exponent of 2 is 0. Therefore, you have to consider 2 square. Here we have 3. Here also 3. Therefore, take 3. Here we have 5. But here 5 square. What is the highest power? 5 square. Therefore, take 5 square. And you find the product of all these. 2 square is 4. And this is 3. 5 square is 25. 4 into 3 into 25. 425 is 100 into 3 is 300. Therefore, the product of different factors with their respective highest exponents is LCM, and the product of common factors with their respective least exponents is HCF. You can find HCF and LCM of any two numbers using different methods. One is prime factorization, as you did now. We just learned the fundamental theorem of arithmetic, therefore we used the same theorem to find the HCF and LCM of two numbers by dividing them into prime factors. You learned both these methods in your previous classes. Now let us write some problems, some sample problems on LCM and also on HCM. Here are some sample questions on LCM. Here is the first question. What should be the length of the room that can be measured with sticks of 3 meters and 4 meters length? Exactly. What should be the length of the room that can be measured with sticks of 3 meters and 4 meters? Exactly. Here we have two sticks. the length of the first stick is 3 meters and the length of the second stick is 4 meters. We have to use these sticks to measure the length of the room. Here, with the first stick of 3 meters length, you can measure 6 meters, and you can measure 9 meters, you can measure 12 meters, you can measure 15 meters, and so on. And with the second stick of length 4 meters, you can measure 4 meters, you can measure 8 meters, you can measure 12 meters, and you can measure 16 meters, and so on. Out of all this, what is the common length? What is the common multiple of 3 and 4? Which is nothing but 12. If the length of the room is 12 meters, then you can measure the 12 meters length using this 3 meters stick and also with the 4 meters stick. Therefore should be the answer. Here is the first sample question. Now next is the second question. Ramu visits market on every second day and Krishna visits on every third day. If they meet today, then when do they meet again? Here Ramu used to visit the market on every 2 days. For every 2 days he used to visit market. And Krishna visited the market on every 3 days. If they meet today, then when do they meet again? It is another question which needs the concept of LCM to solve this. Here is the third question. There are 2 bulbs. First bulb glow for every 6 seconds and the second bulb glow for every 9 seconds. Then find the duration of time for both the bulbs to glow at once. Now to solve this question also, we need the concept of LCM. Now there are some sample questions on HCF. Sample questions on HCF. The first question is, Lavanya has 14 kgs of rice and 15 kgs of wheat. Then what is the maximum size of the covers that can be used to pack the items exactly with same weight? I shall repeat. Lavanya has 12 kgs of rice and 15 kgs of wheat. Then what is the maximum size of covers that can be used to pack the items exactly with the same weight? That is the first question. And the second one, Leela wants to distribute 6 pens and 8 pencils equally to his friends. Then find the maximum number of friends that she may have. These 2 are the sample questions on HCF. And the above 3 are the sample questions on LCM. You students, you also can prepare some questions on LCM and also you can prepare some questions on HCF. First of all, you should know what is an LCM and what is an HCF. And where to use LCM and where to use HCF, you should be thorough in. There is another method to find HCF and LCM which is called division method, and that will be more simple than this. Okay, thank you one and all.